Assalamu alaikum, my dear students. I hope all of you are fine and having good health. So, in this lecture today, we have the numericals related to the Charles law. So, let's have a look at what are the numerical problems and how we can solve this. Before the start of this, you must know that what is the main relationship has been proposed by the charts. So, mainly he proposed that the volume is directly proportional to the temperature, where by removing this proportionality constant, we can get V is equal to K into T, and by rearranging this, the final formula that we got is V over T, which is equal to a constant value. It's mean the ratio of volume to temperature is a constant for the Charles law, and here the pressure must be kept constant. So there is no change in the pressure. So if we have more than two gases, we can also write it as V1 over T1, which is equal to V2 over T2. So we will use this formula for solving the numerical problems related to the Charles law. So let's have a look on the first numeric problem. So the first numeric problem we have example number 1. If 3 dm cube or decimeter cube of air is heated from 300 Kelvin to 400 Kelvin. So here there is a change in the temperature and the volume V1. Here we have the given data, which is the volume V1 of the gas. It is 3 dm cube and the temperature T1. This is the initial temperature we have. It is 300 Kelvin and the final temperature, which is T2, we have it is 400 Kelvin and the pressure is constant. Now, what is the required data for this? Then, what is the volume of the gas? Volume of the gas at higher temperature. It's mean when we increase the temperature from 300 to 400, then what will be the final volume of the gas? So here V2 we need to find. So this is the requirement that we have to solve. For this solution, we must know its formula. So the formula we have, it is V1 over T1 is equal to V2 over T2. So we have all the known values like we have V1, we have T1, we have T2, and we need to find the volume V2 over there. So by putting the values, V1 we have 3 decimeter cube, temperature T1 we have 300 Kelvin, it is equal to volume V2 we need to find, and the temperature T2 we have 400 Kelvin. So by rearranging this, we can get 3 dm cube multiplied by 400 Kelvin divided by 300 Kelvin. Now this Kelvin to zeros at the end, we just gain V2 value, which is equal to 4 dm cube. So this is the final volume of the gas. So in this we have just seen that when the volume of the gas is 3 dm cube, then its temperature is 300 Kelvin. Now, by increasing the temperature from 300 to 400 Kelvin, we have the volume of the gas 3 to increases as 4 dm cube. So, here by increasing the temperature, the volume of the gas also increases. So, we just got that answer from this numeric problem. Okay, so let's have a look on the second numeric problem. In this problem, or in this example, we have the volume of a gas at 50 degrees Celsius. Now we have the temperature 50 degrees Celsius. So given data we have, it is very simple. Temperature T1 we have 50 degrees Celsius, and the standard pressure volume is 500 ml. So volume V1 we have here, it is 500 ml. If the temperature drops to 0 degrees Celsius, now the temperature has been dropped. This is the final temperature T2. We have 0 degrees Celsius at the same pressure. It means the pressure over there, it is constant. Then what will be the new volume? So here we need to find the new volume, that is V2 for this gas. In the first numeric problem, we have increased the temperature. Now here we are going to decrease the temperature. So for this solution, we need to write over there formula. So the formula for this we have V1 over T1 is equal to V2 over T2. So the V1 here we have, it is 500 ml divided by temperature T1. Here you need to know that temperature is in degrees Celsius, so we have to convert it into the Kelvin scale, because in Charles law we use the absolute temperature. So here we have 50 degrees Celsius plus 273, we just gain 323 Kelvin. And this temperature T2 is 0 degrees Celsius. So 0 degrees Celsius plus 273, we gain 273 Kelvin. Now we use this Kelvin scale of temperature. 500 ml, the temperature T1 we have 323 Kelvin, which is equal to volume V2 that we need to find, and divided by the temperature T2, it is 273 Kelvin. So by rearranging this, we gain 500 ml multiplied by 273 Kelvin divided by 323 Kelvin. And the answer we gain, which is equal to V2. So V2 we have is 422.60 ml. Don't forget to write the unit along with the value. So in this, we have just seen that when the temperature is 323 Kelvin, then the volume of the gas is 500 ml, also increase. But on the other hand, when the temperature drops down from 323 to 273, then the volume also drops down from 500 ml to 422.6 ml. So this is a simple relationship that has been proposed by the Charles, that how we can find the volume or the final volume of any gas by changing the temperature. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section, and I will get back to you guys soon. For that time, have a good day, and in the next video we will discuss about the liquid state of matter in detail.